All right, gang, so we're going to continue with evaluating our limits by hand. So just as a reminder, if I had this question, let's just say we had limit as x approaches 3 of 2x minus 1, and we want to find the answer. So what is the shortcut that we discussed? What is it we can do, Eli? Yeah, we can just sub straight in because we know that this is just a linear function. Oh, that's not that good. We know it's got negative in it. We know it's a linear function, and we know it has a point, and it's got a graph on both sides. So we know that the limit is going to approach whatever f of 3 is. So we have this picture. So since we know we have this picture here, then we can just simply kind of cheat and go straight to the point. And so plugging in is how I get the y, and we should get 5. All right. And your other method, of course, is using your calculator to do a table. You could do that, but that's what we have. So now let's pose the problem for today is, let's take another one that approaches 3, and let's say I have x squared minus 9 over x minus 3. So on this problem, at first glance, we're not sure what type of function it might be. Who knows what you would call this function?
Rational.
It is a rational function. Why is that? What makes it rational? What's the key root word in rational for mathematical word? R-A-T-I-O. Ratio, when ratio is a fraction. So think of it as a fraction function. So a fraction with a polynomial is a rational function. So you're right. So this is a rational function. So the question is, I'd like to do a shortcut. It would be nice if I could just plug a 3 in. So I'll plug a 3 in just to see. I don't know if I have that picture, but when I plug the 3 in, the top goes to what? What does the top become?
0.
0. So when I plug this in, I get 9 minus 9 over 3 minus 3, which is 0 over 0. So in numerically, when you get the answer 0 over 0, what that typically represents is this picture. A hole right at where you're trying to get your calculation, but typically there's graph on both sides. So since I have this picture right now, then I can see that, well, there is a limit to it. Okay, the limit should exist, but the way I'm doing it, I can't cheat and go to the point because there's no point there. And I don't want to do the approaches, okay? Well, I want to look for a shortcut. But just to see what the answer is, go into your Y1 and type this in, do your table, and approach 3, and do your 2.9, 2.99, 2.999, that should do it. And then I'll drop down 3.1, I'll go backwards, 3.01, 3.001. Well, it's not going to work in that order, is it? So 3.1, 3.01, 3.001. And you should pretty quickly get an answer, okay? So we will type those in just a second and see what happens, all right? Okay, so 2.9, what did you get? 5.9. 2.99, what did you get? 5.99. Then you should have got 5.999. So this way, it looks like we're approaching 6. If I go the other way, it was 6.1, 6.01, 6.001. So both sides were approaching 6. So we're confident in saying that the answer is 6. But the problem is, I didn't work this problem analytically the way I worked it was numerically I had to use my table. So the question is, how do I do this type of problem analytically? But let's delve a little deeper into the graph. If you now graph this on your calculator, just hit graph. What picture do you see?
A linear function.
A linear function. You just see a line. Can you tell what the y-intercept is on that linear function?
3.
Can you tell what the x-intercept is?
-3.
Yes. So Elijah is exactly right. When you graph this on your calculator, you see this picture. Now, where your calculator is a little wrong, I don't know. I don't know if I should speak for your calculator, Elijah, but for most of them, this is when you hit graph, you see this. Okay, but that picture is wrong. Okay, that can't be the picture. It's just the graph in calculator. It looks like you kind of have a newer calculator, so maybe yours will show it. But something's missing, so your calculator can mislead us a little bit. What, from the information here that we got earlier, if we know when we plug in a 3, there's no point, what do I need to put here? What's missing here? What's wrong with this picture?
There should be a hole.
There should be a hole at 3, and that's exactly what it is. So anytime you try to sub in and you get 0 over 0, it indicates a hole in the graph. Okay? That's what an indeterminate form is. It's going to give you a hole. So at 3, I should have that. And that's why we can't do direct substitution. But this graph is basically the sister of another graph. They're very closely related. It looks like almost like what graph? What if the y-intercept is 3 and I can tell that the slope is 1, what linear function is this? It's this picture, x squared minus 9, is very close. If in y2 you went and graphed x plus 3, you're going to see that these two would lie on top of each other. They're very closely related. Okay? Because if I just graph x plus 3, it's going to look exactly like this, except x plus 3 doesn't have a hole at 3. It's going to look like that. So the question is this: is the limit on this graph, if these are the same linear function, is the limit here and the limit here the same? Are you going to get the same answer?
Yeah.
Yes. Because they're only off by this. This one has a hole, this one doesn't. The limit as x approaches 3 of x squared minus 9 over x minus 3 is the same as the limit as x approaches 3 of just x plus 3. You're going to get the same answer. So if I knew that they were that closely related, I could just do, now if I had this problem here, if I said, look, this one doesn't have a hole, it's got a point. And it's got a point in the exact same spot that that hole is. And if I do direct substitution here, what answer do I get? 6, which is what we got. So the question is this: how are we going to know without drawing the picture that this graph and this graph are sisters, as I call them? How do we know that they have that relationship? So now this is where you got to use skills that you've learned in algebra. What skill can I use to show that this equation and this equation are so closely related? Factoring. That's exactly right. So our goal now today is how do we deal when we get 0 over 0? Well, what we've got to do is we've got to expose that hole and fill it in. What we're going to do is we're going to figure out where the hole is and we're going to fill it in. And once we fill it in, we can do direct substitution. And so now we're going to reset and look at the problem again and think about how we can get to that x plus 3. So We've tried our direct substitution. We got 0, 0, 0 over 0, so we know we have this picture right there. But if I had to point where that hole is, I could just do direct substitution. So Naomi says, look, why don't we factor this? How does x squared minus 9 factor? Yep. X minus 3 times x plus 3, it's difference of 2 squares over the x minus 3. And what you notice is that's what's creating the problem. Because when we're subbing in our 3, that's what's giving us 0 over 0. And that is what represents the hole. So anytime you have a factor in the top and the same factor in the bottom that can produce 0, it's going to create a hole in the graph. This is telling us we have a hole at x is 3. So right now, when I have this equation here, I have this picture. If I do what to these two guys, it will change the picture. What do you think I should do to these two so I don't have a hole anymore? It seems crazy, but what should I do? Just cancel them. If you cancel those, so now if we cancel them out, because essentially they're the same factor, they just give us, it just gives us the answer 1 other than when I plug in a 3. If I cancel them, now I have this function, which essentially has filled in the hole. And I know the limits are going to be the same. So by canceling, I now have the limit as x approaches 3 of just x plus 3, and that one I can do direct substitution for and get 6. So what your goal is going to be is, can you expose the hole? This method we used was factor. So we used factor and cancel. And once you cancel that hole out, it should, basically what we've done is we've filled in the hole, and now we can do direct substitution, okay? So I'll give you another one, see if you can handle that one, and we'll check your work, okay? You should not have to draw the picture. What's going to tell you that there's a hole in the graph? And what is the indeterminate form? What do you get when you plug your x in? What numerically, what do you get? 0 over 0. That's what gives you a hole. Okay, so let's try another one. All right, we'll call this example 2. That was essentially example 1. Limit as x approaches -2 of x squared plus 5x plus 6 over x squared plus 3x plus 2. All right, so there's your 2. Oh, I'm sorry, not -3, -2. I may have said, I meant to put -2. All right. So try that one and see what happens. See if you can plug in your -2 and see if you can get an answer. You don't have to worry about drawing the picture. what happens when you plug in -2.
You get an indeterminate.
Yeah, you get indeterminate. You try plugging in a -2, so the first thing I'll do is try my direct substitution. I get 4 minus 10 plus 6, which is 0, over 4 minus 6 plus 2, which is 0. I get 0 over 0, which tells me I have this picture. So now our goal is to cancel what creates the whole. And I already know it has to be an x plus 2 factor. What is telling me that it's an x plus 2 factor?
There's a whole x equals
At -2, so it has to plug in and create 0 somehow. So I know I have to cancel this factor that will get rid of the whole. Okay? So now we're going to factor it. So both of those quadratics should factor with an x plus 2. So the top one's x plus 2 times x plus 3, and the bottom one is x plus 2 times x plus 1. And now, think about it, that right there is basically always 1, except one time, it's not 1, right? Because that's mainly 1 is the answer. But when I plug in a -2, so right now I have this picture, a -2, where I don't know my y, I'm probably messed up on the y, but I have this picture. Once you do this, you do this. And now you can do what? Once you have that picture, now what are you allowed to do? Direct substitution. And you plug it straight in, and it looks like we get what? 1 over -1, which is -1. So my picture is a little, here, I'll fix my picture there. All right, that's what happened. Okay? Now you got, it's a shortcut, it's a trick. The only problem is factoring is not always going to be the way to solve the issue. Okay? So I'll give you another one. All right, ready? Best if I take one out of the book, that way we get one that's not too hard. All right, so one technique for eliminating, for dealing with this indeterminate form, we use one technique which we're doing factoring cancel. The next one, this is a type of, we'll call this one example 3. Limit as x approaches 0, square root of x plus 1 minus 1 over x. So this has a radical in it. But you're going to see, I know that I have this same scenario at 0, whatever the answer is. I know that this is the scenario. Okay? Because if I try the direct substitution, I get 1 minus 1 on square root of 1 is 1, 1 minus 1 is 0. Plug a 0 into the bottom, I get 0. I have that picture. But factoring is not going to work, right? Because it's not a polynomial, I can't factor it. However, I do have another trick, okay? And here's the trick that we're going to use. Anytime you have a radical, when you have a square root, you can multiply by the conjugate. And that will then change the form of the problem and allow us to cancel. Let me ask you this. What is it you think? We have to cancel something from top and bottom. What do you think it's going to be? The last problem we had to cancel an x plus 2. Why was it x plus 2? Because we were plugging in what number?
2.
Not 2. -2. Now we got to plug in a 0. How can you plug in a 0 and get 0 over 0? 0 has to go in for what? X over x you're going to have to cancel. That's what's killing the problem. You just don't see it right now. You're going to have to cancel those factors, x over x. Okay? So I need to get, my goal is to get limit as x approaches 0. X times something over x times something. And then once I cancel that, now I'll fill in the hole. So I'm trying to lead you to be thinking about what you have to get. So now, how do I do that? Well, I'm gonna multiply. So when I have a radical, do you remember what conjugate is? You look at the radical. The radical, this is -1. The conjugate is the radical, change the sign, +1. Square root of x plus 1 plus 1. But whatever I do to the top, I have to do to the bottom. So this is called rationalizing the numerator. In algebra, they lead you to believe that you always are trying to get square roots from the bottom to the top. Well, in calculus, most of the time, we got to move the square root from the top to the bottom. All right, so now you got to multiply. Now look, don't multiply out the bottom. That's why I said think about what I need to cancel an x, so it's x times this. So don't worry about multiplying the bottom out. Just say x times that parenthesis. But do the top. When it's conjugate, you need only do first and last, because outer and inner will cancel. I'll show you that. Okay. So if you multiply it out, reduce your problem, you should then be able to cancel what's causing the hole. So just because we're running low on time, I'm going to walk us through this, that way we can finish this filming about 22 minutes in. First, so square root times square root, we just lose the square root. If you want to do outer, you can. Square root of x plus 1 times 1 is positive square root of x plus 1. Inner, negative square root of x plus 1. Well, those are going to cancel anyways because they're conjugates. Last, -1 times -1 is -1. All over x times this radical, square root of x plus 1 plus 1. So now, after I cancel that outer and inner, what cancels on the top? What additionally? 1 and -1. And so now you're left with the limit as x approaches 0 of x over x times square root of x plus 1 plus 1. So you still have 0 over 0. So now what does this free you up to cancel? What can I get rid of? What do I have to cancel?
X over X.
Yeah, x over x cancels, leaves you a 1 on top. And now you can do your direct substitution. So now when you do direct substitution, it's into this. And you get 1/2 as the answer. Okay? That's how you handle radicals. So when you have radicals, you got to multiply by conjugate, top and bottom. Okay? What's always the conjugate? You change the middle sign of the radical expression. That's the conjugate. This is the trick. Okay? We'll do one more real quick. I need to show you. One shouldn't be as bad, but we'll see. Okay. All right. So if this was a little confusing to you, here's the good news. You saw in the film. Go and watch around the 20-minute mark. We worked this problem. Go through it again. Okay. All right. Last one. The last type of situation you're going to get that you got to try to cancel a whole. So you have a factoring. You'll have a radical. The last one is a fraction. You may have a fraction that you need to get rid of. So let's say you have limit as x approaches 0, 1 over x plus 3 minus 1/3 all over x. So you got a fraction inside of a fraction. It looks awful. But direct substitution doesn't work because top goes to what? Plug in a 0, 1/3 minus 1/3 is,
Zero.
plug in a 0 on the bottom goes to, this is the bottom, all that fractions up there are the top. So your method on this, when you have a fraction, you're getting 0 over 0, is combine into one fraction. Okay, combine into one fraction. So the way you combine into one fraction is you got to go back to the top and get a what? That's the word combine. So go right here. You have two separate fractions. How do you take two fractions, make it one fraction?
Multiply each of them by the other. Multiply them by like one, so it's like the other over itself.
It's called getting a common denominator.
Yeah.
Okay? What you would have been taught in algebra, getting a common denominator. Common denominator means you always need, if you had 1/5 plus 1/7, what's the common denominator? 5 times 7. The two denominators multiply. So you multiply this one by 7 over 7 and this one by 5 over 5, which allows you to get 12 over 35. That's how you make it to one fraction. You do the same thing here, except this is like my 5, that's like my 7 there. So I'm going to multiply this guy by 3 over 3, and I'll multiply this guy by x plus 3 over x plus 3. So now when I do that, I have the limit as x approaches 0, 3 over 3 times x plus 3, minus x plus 3 over 3 over x plus, over 3 times x plus 3, all over x. So there I got a common denominator. And now that I have a common denominator, I can make the top one fraction. So I get the limit as x approaches 0 of 3 minus x minus 3 over 3 times x plus 3 all over x. So notice when I made it one fraction, I distribute the minus right there. All right. Now what? What do you think is next? So I just put combine into one fraction. I'm still not one fraction because I have a fraction inside of a fraction.
You distribute x into the numerator.
In a second I will. But what do you think I should do first though? Something is glaring right now. Yeah, how do I simplify?
You could cancel the 3.
Yes, you need to cancel these two 3s, 3 and negative 3. So it's more than just combine into one fraction. As you're getting a common denominator, you need to try to simplify. So now, believe it or not, that is the key to now allowing us to eliminate the whole. Because don't forget, the problem with this is a whole. And here's what Elijah's saying. He's saying this x down here, believe it or not, is going to cancel with this x. It's just not obvious right now. It's hard to see. So technically, the rule is this. When you have a fraction over a fraction, it's like having x over 1. But I'm doing division. I can change the operation from division to multiplication if I do what to the bottom? So right now, this is divide by this. I can move this up if I do what? Make it the reciprocal. So I'll make it times 1 over x. And now once you do that, you can see that this x and this x are still what's blowing up the problem. See, if I plug in a 0, the top is 0. I plug in a 0, the bottom is 0. But now since it's multiplication and they're in opposite spots of the fraction, I can do what? Cancel. You're left with, sorry, running out of room. The limit as x approaches 0. That's a negative 1 over 3 times x plus 3. Now you do your direct substitution and you get negative 1/9. Not 1/6, because when that goes in, 3 times 3 is 9. Okay. And those are the 3 main methodologies you would get for eliminating a whole. Is factor and cancel. If you have a square root, multiply top and bottom by conjugate. So multiply, let me put top and bottom by conjugate. fractions combine into one fraction by getting a what is it that we had to get? Common denominator. And simplify, okay? So those are the three main types that you will get. Okay. All right, so I'm gonna stop it right there because, all right, so